Good morning, everybody. Or good afternoon, actually. Can you tell I've been awake a lot? Thank you, the few, the proud, the brave, who've made it to the end. Wonderful to see you all today. My name is Colin. I'm the product manager for UAR. And today I want to talk to you a little bit about our forthcoming AR Cloud SDK. So let's start. So first off, a little bit about my company. We're based in Portland, Oregon, the Silicon Forest. We're about 600 miles north of Silicon Valley. There's actually quite a few tech companies up there. It's home to Mozilla, Intel, Airbnb, and a bunch of other companies. It's really wonderful, and the housing is a little bit cheaper, so I can afford to live there. So UAR was started in 2015 by veterans of the animation industry. And when I joined, they told me, we want to create cinematic immersive experiences. The problem was, it was 2015, and we started looking for an off-the-shelf computer vision solution that would give us persistence, so that a character I place on this table today still is on this table tomorrow when I come back. And we wanted occlusion, so that my AR animated character disappears at the right time when he walks behind this table. And we wanted collision, we wanted physics, so that if I shoot a ball, it would bounce off the right thing. And we weren't sure that we could achieve that with any of the computer vision that was out there. And every time we found computer vision that we liked, some big tech company would buy it up and it would go away. And we were very frustrated, and we decided it's time to develop our own computer vision solution. And out of collision and occlusion and persistence, we decided persistence is the most important thing. If there is one thing that we need, it is for our content to last in the same location, because there are so many wonderful use cases that are enabled by that. And so we started building our own computer vision, and we knew it needed to be monocular, depend on a single lens, and we didn't want to use markers. We think markers are nice in certain scenarios, but inelegant in many others, where it kind of hurts the narrative if you can't just point out a real location, but you need to add a sticker or something like that. And so we didn't realize it right away, but inadvertently we were building kind of the building blocks of what Ori Inbar later termed as an AR Cloud data set. And so we didn't even quite know what we were doing, but then we started attending events like AWE and talking to the right people, and we realized, oh, I guess what we're making is AR Cloud. So just a quick reminder for anyone who is wondering, what is an AR Cloud? It's this shared soft copy of the world, and it's optimized in a way that AR-capable smart devices, robots, autonomous vehicles, it helps machines understand the world. And it can be made out of many different things. Depending on which AR Cloud company you talk to, some of them will say, only point clouds. But we at UR believe that an AR Cloud is any information about the real world that helps inform a device about its location in space, helps enhance that experience in some way. If that information is useful to the end user or to the device that's facilitating the experience, then that's data we want. And so point clouds especially is the fundamental data set that usually is in AR Cloud, but there's lots of other things that can be there as well. And it doesn't have to be, but a good AR Cloud has to be updating constantly, because the scene changes. The room we're in right now, after this talk, someone is going to come and take all these chairs out. And if I had built an experience in this room, I would want it to last, even though the transient features of the room has changed. So a good AR Cloud has to constantly be incorporating new data as the environment changes. But what does it make possible? Well, like I mentioned earlier, it lets you do occlusion, collision, and persistence. And beyond localizing that device in real space, it also, because that data set is collected somewhere online and can be redistributed, it lets you share this experience with multiple users. Right now, if I download an AR app off the iOS store, many of them are what I would call a siloed experience, where I do it on my phone, only I see it. If the person next to me opens up the same app, they see their own version of the same experience. We don't share one experience together. And that's kind of frustrating. We feel like the best narratives, the best cinematic experiences come out of something that we can experience together. And so that is fundamentally what an AR Cloud lets us do. Also, because of this focus on smartphones and head-mounted devices, the AR Cloud data sets that get built help capture what we sometimes call the last meter. And these are the spaces that aren't being captured by satellites, LiDAR, cars driving down the street, drones. If you want to get sidewalks, the insides of shopping malls, if you want to map the inside of your home, that's something you basically have to do by hand. There's not really something besides a person that can capture these spaces. And so this, I just wanted everyone to understand what an AR Cloud is. And I would argue that 2019, this year, has been the year of the AR Cloud services. I have seen so many products come on the market, and that's wonderful. I am so glad that AR Cloud is not just a beautiful idea that we're talking about anymore, but we're starting to see realized products out there. We've got Google Cloud Anchors, Microsoft has their Azure spatial anchors, Facebook is starting to talk about live maps. I am curious to hear more as it develops. Magic Leap also has their Magicverse. Again, I'm curious to know more as it develops. And then we've been seeing some really awesome work from some of our comrades, some of the other AR Cloud startups, 60AI, Escape, Eighth Wall, Immersal. They're all doing really awesome, really practical AR Cloud tools that you can use today. But there's something in common with all the products that I've listed for you here. They're all centralized software as a service products. And that's great. That's great for so many use cases, especially B2C, where an individual doesn't want to be concerned with hosting their own content. Software as a service makes so much sense for that. But one size does not fit all. SaaS is not for every use case. So when might you have a rich spatial data set that you want to be able to leverage and distribute to people, but you really want to be able to control that as well? Well, what are some of those use cases? A corporate campus, maybe where you have proprietary trade secrets, maybe even the layout of the building is a trade secret, but you still want to be able to paint that campus with data. You need to store that data yourself in a way. You need to be able to collect that data in a format that you can control. There's also a lot of other situations. What if local legislation requires very specific treatment of your privacy data? We're here in Europe, GDPR, very important. If you want to do business in Europe, you must observe GDPR. In the United States, we have COPA, which is a Child Online Protection Act, essentially, restricting. So what if you have children playing video games in your AR Cloud platform? You have to be very careful about retaining data related to their activity. So there's all these circumstances where you want this fine-grained control that you might not otherwise have. I'm from Minnesota. In Minnesota, if you have medical data that your hospital is storing, they have to store it in the state of Minnesota. It doesn't even have to stay in the United States. It has to stay in the municipality where you are. And so there's all these nuanced privacy requirements that you might want to meet. And you can't send your data to a third-party service. You need to be able to hold it. And there's also these walled garden issues. And so I look at the giant players, the Facebooks and the Googles of the world who have so much resources that they can build their own AR cloud and not worry about interoperability or compatibility. And those experiences can be wonderful, but if I, as an individual content publisher, buy into that ecosystem, I might be limiting myself. I personally want to be able to put my content out in as many ways as possible. And I don't always necessarily want to be subject to the content policies of a third-party host. They might have some rules about what spatial data they're willing to host. And if I have an alternative where I can host it myself, I can build whatever narrative I want. So let's step back for a second, and I want to talk a little bit about the history of the internet, maybe draw a parallel to what I'm seeing with the development of spatial computing. Does anyone remember these blogging platforms? Blogger, LiveJournal, MySpace. Where did they go? Some of them are around just a little bit, but they're shallow husks of what they once were. What happened to them? Well, I have an idea, and I kind of borrowed this idea from Jonathan Zittrain, who's an awesome Harvard law professor. He's written a wonderful book. It's from 2008. It's an older book now, but it's still a great read, The Future of the Internet and How to Stop It. And in the book, he essentially argues that most new technologies, especially internet-connected technologies, they kind of start as a walled garden. And inevitably, the users find a way to break out of that walled garden. It's essentially this cycle that happens with every new wave of internet technology, where it starts as a closed system and it ends up being an open system. And as an example, he offers up stuff like CompuServe or AOL. Anybody in the room remember using these? So you'll notice I don't have a search bar, I don't have a URL, I only have buttons. They only want me to access the content in their walled garden. And how did we get beyond this? Well, when I was a little boy and I had America Online, I would open up America Online, and instead of clicking on these buttons, immediately I would open up Netscape Navigator. Once AOL got me on the internet, I immediately left AOL, and look, I have a location bar. I can go anywhere I want. And I'm starting to see parallels in the spatial space. Anybody play with an Oculus Quest recently? Bunch of big buttons, very cool, but rather a closed ecosystem. And so I think of all these blogging platforms that came before, and I go, what happened to them? Well, something called WordPress came along. And people found it really useful, and WordPress was smart. There is WordPress.com. You can use WordPress as a software as a service, where if you just want to write and you don't care so much about controlling the content yourself, you can go put it online and they'll handle all the server infrastructure for you. But they also open sourced their technology so that anyone could take that stack, host it on their own server, modify it how they want, build any narrative, any story, anything they want to put online they could do, because now the publishing tool was under their control. It's a de facto solution for the entire internet now. As of 2018, 30% of the internet, and when I say the internet, I'm really talking about the most visited sites. And I'm not talking about the dark web, I'm talking about the daily internet that most people use. 30% of it is WordPress. We really admire WordPress at UAR, and we hope that the stack that we're offering can offer some of those same advantages. For the spatial web, for the spatial computing platform of the future, we want to offer a hosting solution that individuals can control. And so, our UAR Cloud SDK, forthcoming in private alpha at the moment, it provides the tech necessary to persistently anchor multi-user experiences, just like some of these software as a services do, but you host it yourself. And I'm going to get into more detail in a second here, but let's keep going through the slide. So we made it cross-platform out of the box. We felt if this is truly going to be a do-it-yourself situation where you can host it any way you want and consume it any way you want, we have to support the devices that are in everybody's pocket. So we've had a focus on Android and iOS, and in the near future we have builds for things like the HoloLens, the Magic Leap, perhaps the Quest in the near future. And how our computer vision system works is we have what we call a consensus network of re-localizable AR anchors. And in a minute here, I'm going to invite my Chief Technical Officer on stage to get into a little more detail about that. But we think this technology is most valuable for situations where it's a private space and you want to be very careful about who you vend that data to. And you might have your own robust security, so you're a corporate campus and you only send that information through your privately encrypted Wi-Fi system, and it has to be an authorized user with particular identification built into the device they're accessing through. And so we've created a point cloud management system that can be integrated into just about any server stack you want, so that you can host your own AR cloud. One thing I really want to point out, though, is our SDK doesn't require you to send anything into the cloud at all if you don't want. That entire database can live on device, because there are many use cases, especially with things like GDPR in mind, where there's legal ramifications for sending your data to the cloud, and you need to keep it on device. And so we're building towards a concept of isomorphism, where eventually all the processing that happens on the phone right now can also happen in the cloud. But first, we wanted to make sure it could happen all on device for circumstances where you really want to isolate and maintain the security of the experience you're building. And so our SDK, it's built in Unity. We've just actually upgraded it to support Unity AR Foundation. It works alongside native computer vision solutions, so it doesn't replace AR Core or AR Kit, it complements it. It further stabilizes the visual odometry and sensor fusion already offered by the native solution of whatever hardware you have. So AR Core, AR Kit, the most familiar, but something like a HoloLens or a Magic Leap has a different set of sensors, and we also try to leverage that data to kind of get the best sensor fusion possible. So let's talk about the computer vision driving this for a minute. Now, I've told you all about the hosting aspect of it, but whether you host it on the cloud or on device, what really matters is how do these spatial anchors work? What does it let me do? How? So, like I mentioned before, cross-platform, works on the most popular devices out there, more coming soon. One thing we're very proud of, and I'm going to show you a video of in a little bit here, is it works in changing environmental conditions. So far, we've been very focused on lighting and transient features because these seem to be the biggest issues. And in fact, if you go on the documentation for AR Core or AR Kit, they just tell you how many lumens in the scene are required. They don't even say it will work in the dark or it will work in the very bright. They just say, hey, this is the only range in which our anchors reliably work. And I won't claim that we have the magic bullet that works 100% of the time, but we have worked very hard to create a system that adapts to a lot of different lighting conditions and isn't limited to a particular lumen range. And as the scene changes and stuff gets rearranged, new point clouds are generated to help compensate and continue to anchor your experience to the same location, even as the chairs in this room get rearranged, something like that. Our system lets you create specifically provisioned privacy policies to facilitate, again, your niche use case where you must observe certain policies in the way you're handling this spatial data. We also offer very low-level access to the anchors themselves. This is something that a lot of the bigger systems kind of keep as a black box, so you can't really see what's inside. Again, we want to really put as much control in the hands of individual developers as possible. And like I mentioned before, we really try to complement native CV solutions because battery life is a costly thing, processing power, data usage, and so we don't want to leave anything on the table. We want to leverage everything that's already there and really be efficient and only use our muscle where it's going to improve what's already there. So yeah, right now it's a Unity plugin. Later we will probably support additional things, maybe Unreal and Godot we are looking at next. And then our point cloud database situation, right now it's deployable via Docker or Kubernetes. You can host it on AWS if you want. You could also build your own server right on your corporate campus, control the hardware, control the software, really have 100% control of your stack. It's up to you. So at this point, I want to invite my Chief Technical Officer, George Blikas, onto stage. He's going to bring you through some videos demonstrating our AR Cloud library in action and kind of explain what you're seeing, tell you exactly what's cool and unique about this. So George, come on up.
Hi. So I'm going to talk probably more in depth about this list of features here. As Colin said, there's this hosting aspect of it, which goes to this sharing. Other APIs use hosting as a way to validate data and secure your data. Google AR Core does a great job at this. When you want to localize with AR Core, their API has you actually send a geolocation request to a server in order to verify or make sure that you are indeed where you are, and you do not download data you do not need in order to do the relocalization. That's great for a lot of use cases, as Colin mentioned, with like GDPR and other things like that. But really, when it comes down to it, we want to be able to traverse our 3D space in a way that makes contextual sense. You want to be able to walk down a hall with a piece of software that's AR enabled for an AR experience, and you don't want to have to make constant context to the server. Maybe you're hopping networks, maybe you're doing something else. This first video I want to show you actually is about exactly that. You're going to see walking down the hall, and you'll see these little cubes appear, and those are actually the anchors themselves. So when you have a persistent AR experience, those anchors are really about how the experience gets launched, and as long as you can find one of those in your 3D space, your experience can start and will persist over time. Do I just play by hitting next?
Yes.
Yeah? Okay, so the coloration on the screen matches with the coloration of the cube, identifying each anchor as you traverse the space. There's about 5 here, I believe. The names are randomly generated. It's just a human readable one instead of 0157 something that you won't be able to read. And as we traverse the space, everything that's colored you can track too. So I'll play that again so you can get another look at it. It goes by kind of quick. But the really key piece about this is that you're seeing all of these in the current runtime. I'll go back to that piece of code that we had up there in a couple videos from now, and that actually plays a really significant role in our SDK. So behind our SDK, we want the ability to traverse content in a dynamic loading and unloading fashion, so that when you're looking at one piece of public data, you can see filtered content for even the private ones if you have permissions to do so. And to look at them across a variety of environments is what is also of like primary importance in AR applications. If you can't, track to a building that you generated a scan on during nighttime, that's far less useful to you if you spend all this time during the day pre-scanning it. Not to say this like magically works. It's not like you can shoot this in pitch dark and then you turn over to mid-noon and everything works fine. But you'll see me move around these objects on the table, as well as turn these lights from a daytime simulated morning, and then we move to a simulated daytime and then a nighttime. And as you see these pick off, you can see the different colors pop in. And what's actually happening is we are intelligently expanding our anchor network in order to facilitate these lighting factors. And again, even though those are all in the same scenario, all in the same scene there, the object in which you place in the 3D space will actually be anchored with a shared understanding, so that whether you've localized to the red one, the yellow one, or the simulated night, your object will stay where it should in 3D space. So sort of extrapolating the concept of a single anchor to something more dynamic, and that's why we coined it an adaptive anchor network. And so sort of you can think of the anchor as the whole space. Then there's a content side to it, as I was describing. So in content, we want to be able to move to both have data for it and not have data loaded in for the actual trackable itself. So there's some sort of dorky asset that comes in here. It's there to illustrate orientation. But here, I had 2 scans in my network. That's why they were on the same level. And I placed a piece of content on one. Then I unloaded it. Maybe you didn't download it from your server. Maybe somebody turned it off for optimization. We tracked to the alternate one. And when we look over, the object is actually where it should be in 3D space. So these three factors combine to provide a very dynamic set of features that accomplish what we envision as a whole AR cloud stack and what is necessary to actually accomplish it. When you download our SDK, because you have such low-level access to the anchors and to actually these networks themselves, you have the ability to sort of launch super in-depth and very unique experiences loading huge amounts of data. So one other thing this facilitates is like, maybe you don't need like every asset from every scan. You don't need every scan themselves, so you keep it off device, and then you never have to download it from the server, stuff like that. And I did want to revisit this. Does this work? Yes. Okay. So that last video you saw was utilizing this part of our SDK, and when you ask it to localize to something known, it's as if you were tracking to that thing alone. And if you were localizing to something unknown, we attempt to go ahead and position the content in 3D space. And that's really all the on-device story. You can do that all on-device through our SDK, but then we really move to this point cloud database example. And really this goes on to perhaps a sharing sort of scenario. We use it primarily in our use case to hand off scans from one device to another device in order to have them both see the same space. And we use a platform agnostic anchor so that you can do the same thing on Android as you can on iOS. And let me go through to the end. So we're in early access right now. The key differentiating features from some other SDKs that we've heard of in the past is really this dynamic changing lighting conditions, the adaptive anchors, as well as we can actually leverage some other software-driven APIs. So one common one is 6D AI. It's one we get a lot of questions about. In the near future, we're going to have an API that SDK example which uses 6D AI. So the content now becomes geometry itself, and you can go ahead and load in the geometry persistently based on our SDK and still share it with another device that may not be 6D AI compatible. Again, this is the only AR cloud solution which enables you to host your own spatial data on your device or on your servers. We want to make sure that the hackers that are in us out there have the ability to actually access the data they want to develop on. And then the early access dev kit will come with both the plugin and the microservice for the point cloud. You can visit us at uar.io/early access if you want to sign up for our letter and be first on the beta or alpha list. Pretty soon, I think we're actually going to be opening it up into where Colin was mentioning. We're in alpha level. Hopefully, we'll be opening up into beta soon. We want to get some more partners in and more testing on the solutions they want. And we're really looking for, as you sign up for this, we really have this broad AR cloud vision in mind. And so I'm always open to taking these, I don't want to call them bug reports because I think sometimes they're much more helpful than that. It's like if you have a use case in mind that the SDK is not working for, we want to hear about it. Because to build that AR cloud, you need this wide range of samples, right? Like I don't know what developer A wants and I don't know what developer B wants, but maybe I've heard from developer C and that's not so bad. Maybe that's our next feature that we incorporate. So we're always looking for ideas centered around that. I think I maybe want to pause and answer questions about the SDK.
Before we open it up to Q&A, I'm going to come back on stage and I just want to emphasize a few of the maybe not so obvious advantages of our approach here. So that adaptive anchor network system that George showed you, some of the other AR cloud solutions out there generate a large point cloud with tons and tons of points. Some do a large point cloud that's sparse. Either situation, you're dealing with a very large data set spanning a very large area. And that can be frustrating to a device with limited memory, limited battery power. And so our adaptive anchor network system not only helps us anchor content in a way where it's got multiple anchors that it can rely on to know its location in space, it also helps us be kind to the battery and the memory of your device. Because instead of taking the whole world as a whole, we chunk it into these discrete subsets of AR cloud. I mean, we call them anchors,
yep.
but They're really, neatly chunked pieces.
Oh.
And we provide variability in the density of the clouds you want. One feature of our SDK is how many variables we expose to you. So you can adjust the range of precision. We can do up to 30 meters, but it all depends on how dense or sparse you want those point clouds to be, what lighting conditions you want to tolerate. So we provide you this low-level access so that you can really tweak to individual use cases in a way that's going to make sense for you.
Actually, if we could get the slides back up, there was something thank you for pointing that out. So one thing about that walking down the hallway example, lots of people will say, well, why don't you just make that one giant map? Okay, we could do that. That poses some data size problems in a lot of use cases. Another one is people say, well, can you scan a 100,000 square foot warehouse? Yeah, we could scan a 100,000 square foot warehouse, but that's not really helpful, especially because a lot of these software solutions that do the relocalization need something called loop closure. Because if you're going to use a single map and you're going to traverse a giant space, at some point you're going to start occurring this drift. So when you start at the front door, make your loop around the outer edge and come back to it, you're going to have this disconnect where it thinks that your pose is maybe a meter, 2 meters off in a good case. But as you use our multiple anchor network, you actually, as you actually use this and roll through the scene, because we are tracking intermediarily to these other things, you actually remove the need to have a piece of software that actually needs loop closure. Not like we can't have it, but it definitely alleviates a lot of those technical problems that come with it. So you can sort of get off path halfway. Maybe your device gets bumped. Maybe you're tracking based off of a forklift or something, and the driver just goes veers off course a little bit, and you can get back on track via our multi-mapping with persistent anchor experience. So that's a really good point to bring up, Colin.
Yeah. Any other details you want to cover before we open it up for a little Q&A?
No, I think that's the only thing.
All right.
So thank you very much first.